Hi, in this video, I will show you how to do Project 2, how to design a NoSQL database. Although there are many different kinds of databases in terms of NoSQL types, such as key value, columns, graphs, documents, but in this project, we will focus on learning how to design a key value database. And the reason because the key value databases are basically the core, the basics of many other NoSQL databases. Then, to implement our design, we would use Redis. And the reason that we choose Redis is that because it is basically number one, the most popular key value database in the last 3 years. Now let's go back to our project. First, what are the project requirements and instruction? You can download the project note number 2 under Unit 7, NoSQL Design, and that's where the requirements and the instructions are. Then you may also like to download and have a look at the example of the report and get the template file using which you can fill in information as you do your project, just like in project 1. So let's say we have a working folder called P2 database design, and we download all of the necessary files, the project note, the report example, and the template. Now let's go back to the project notes. Under project requirements, the first step is just like in project 1. We need to make up a business situation where we have to design a database for a company or organizations. And the difference here compared with project 1 is that it's very big. The company has to be very big, has a lot of customer, and the requirement is that the information need to be pulled out, be displayed, or changed very quick. So it has to be fast, although it's very big. That's the challenge. Then the next step is to define the business applications. So unlike relational or SQL databases, the NoSQL databases are, as we know, developer or application centric. It comes straight based on the application. And that's the reason why we need to look at the business application first. So in this project, you need to make up an application for certain kind of activity or business transaction within the given company. And since our final ultimate goal is to create a key value database, so therefore be careful when you build or make up the business application, because in the next step, select appropriate database type. You would need to explain that why the key value database would be the best choice. You can read more explanation about that part if you go down over here. Okay, so here in this first step, let's say in this case, an example is that we create an imaginative company which is very big for transport and shipping. And for that company, let's imagine that we need to build an application which would look something like this. Okay, it displays the ID of the account and show the customer information, summary of the shipments, how many packages, from where to where, and the total price, and also the alert information, where would you want to send the notifications, to your email if it's a pickup, or text to phone if it's a delay, and obviously it also show the current location. Then the next step is to define what kind of database type would be the best. And so we will need to argue that first, it should be NoSQL, not relational. And the reason for that is, let's say if in order to display information in that app or software, if we use a relational database with many different tables, as we know, then in order to display the information on the app, we would need to pull the data from different kinds of tables, filter here, filter there, combine, put them together. And that could be a problem when you have a lot of customers, in this case, hundreds of millions of customers or users at a time. And that is exactly when a NoSQL database would be needed. Now, however, we have many different kinds of NoSQL. So which kinds of NoSQL would be suitable? And since our final goal is to work with a key value database, so therefore be careful when you make up an app for your project. Make sure that it falls into this category, either user profiles, preferences, shopping carts, or store session information. So in this case, the example that we have in our report example is that we have an app that shows the user profile, customer, the preferences for notifications, okay, and so that's why we can say that key value database would be the best choice. The next step would be to define the logical design, and the first thing is to define the data model techniques. So if we look carefully at the interface at the app, then we see that it looks almost like a table, but not quite. But if you divide it into different parts, then you probably can have a set of different tables. And that's tell us that we probably should use a model technique called emulating tables. On the other hand, the items, for example, name of customer and the currency that the customer prefer, usually go together, and so we can group them together, or in other words, use the aggregate techniques. And it's the same for the dashboard area, where information that summarize the shipment should be grouped together, and the same about the alert, the items to specify what is the user preference for getting the alerts. Then the next step now is to define the namespace, key, and the value structure. Okay. In this case, we don't have a lot of data and it seems that there's no overlapping, so we can probably be okay with one namespace, which we call, let's say, tracker NS. And we notice that right on the app appearance, there's an ID, which is the user account or the account number. So we can probably use that as our key because you can uniquely identify customer and shipment and other things. So now if you remember, the concept of the key value model is that we have many pairs key which uniquely identify the value. Now the value, you can think of it as an object that has many different entities: current location, a symbol structure, in this case the city, let's say Paris, customer entity that has two fields, the name and currency, the shipment entity that has four different fields, from where it comes from to where of the destination, number of the packages or the items, and the total price. And then we have the alerts where we can kind of like put them closer to each other. We can have four items knowing the first one is always the email, the second one is the kinds of notification that we want to send to the email address, and then the phone number, which would be the third item, and then the last one, the fourth one, would be the type of the notification that we want to text to the given phone. The next step is to name the entities. Okay, so in this case we can see that there are four entities that we want to separate. The first is the shipment current location, which comes from here, you can see, and so we will need to name it, and since they all belong, these four entities all belong to the same account number, and so this is the technique in key value database where you make up the name for a key. In this case it has two parts, the entity, okay, and the account number. So now we want to reduce the length of the key because the shorter it would be quicker. So for location we just have lock. Customer information we have cost. For dashboard or shipment summary we have dash, and then for alerts notification we have ALRT. Then the next step, we want to define for each attributes and fields of each entity. So the first one, to show the current location, the key would be lock, and then the ID, and that the value would be the current location, which is the name of the city where the current shipment is. Then for the second entity, which has two fields, then we have the key would be consisted of cost and then the key ID, and because this is two fields, so over here you could see that we have name and then we have currency. Similarly, for dashboard entity, we have the key would be dash and then the ID, and in this one we have four attributes or four fields. shipping from city, shipping to city, shipping count, how many items, and shipping price. And the last one for the alerts, this is although has 4 items, but it's a little bit different. We don't really have to separate them completely as in the previous one, okay, because somehow they kind of like relate to each other in pairs. So first we have email address, and then the kind of notification for that email address. Do you want to send the pickup information? Do you want to send the delivery or delay notice to the email address? And then we have the phone number, and then what kind of notification do you want to send to the phone? The same, you want to send the delay alert or cancel alert, etc. Then the next step is to define the data operations. So in this software application, what can the user do? The user can view, which means we have to make sure that we can read the data from our database, and so that we can display it on the software interface. And then the user should be able to update certain things, and that means we should be able to do the right operation to our data. So at the end, our key value model would look like this. All of our data would be in pairs of key and value. The key is the ID, the account number. The value is a complex object that has 4 entities. The first one has simple structure, lock, current location. The second one, customer, cost, has 2 attributes or 2 fields, and the dash has 4 fields. The alert has 4 items, but they don't have to be separated completely like in dash, and so we will see that we can use a slightly different structure for this entity. So that was the end of our logical design, and we will continue in the next video how to implement this logical design, or how to do step 5, create the design database.